Well, I will begin with a word of prayer. I think it's time, give or take. Don't worry, I am my own cameraman today. So let me pray. Holy Father, we thank you for this day. Again, Lord, I thank you for these students. Just pray that you'd guide our thoughts today, help the students to prepare for the test tomorrow. Just do their best, Lord. In your name I pray. Amen. Let's see here. So I guess you probably want to look at the quiz for a minute. Number one, you may have forgotten, but we did in fact give a definition for what it means for a limit for a sequence to converge. And I drew a picture and stuff, but basically the definition is this: if for each epsilon greater than 0, you can find a natural number such that whenever you're beyond that natural number, the distance between the sequence and the limiting value is less than epsilon, then that means the limit of a sub n equals to L as n goes to infinity. So I'm guessing not many of you wrote that. But anyway, that is a definition that you should know. Now, this one's a little bit more mission critical. If you don't know this definition, then it's really hard to work certain problems. So we say that the series with term a sub n converges if and only if the limit of the sequence of partial sums converges to L. Right? This is the sequence, the nth term in the sequence of partial sums, right? Which is a1 plus a2 plus an. And then this, we have a nice notation for this, which is this summation j equals 1 to n of a sub j. But this, of course, and that are exactly the same thing. I hope so. It's best to have everything that's written here, but this is the main event. Having this equation will make me very unlikely to take any of your points away. Yeah. This is a proof we did in class. I won't talk about that. Any questions? No. This one. This is actually my example going forward why the method of L'Hopital is insufficient to solve problems that you might run across. I mean, pragmatically speaking, L'Hopital's rule doesn't really work that well. I mean, I think I have a calculation I left in my office that after about 5 or 6 applications of L'Hopital's rule, some of which were very unpleasant, I eventually get to a third. I mean, it's nasty. And but on the other hand, if you knew about these things called series, this is the series expansion at x equals pi over 2. At x equals pi over 2, this function here can be represented by 1/3 plus 1/15 times x minus pi over 2 squared plus stuff, right? What happens is x goes to pi over 2. Dead, dead, dead. Everything else is dead. Just leaves you 1/3. So if we knew series expansions, it's a piece of cake. That was not actually the example I was trying. That was not the point I was trying to make. But I knew this is a hard problem. I didn't know how hard it was, which is part of the reason I gave you guys how many bonus points? Yeah, like a bunch of bonus points on this quiz. So if you didn't get that one, it's understandable. As far as I know, through elementary means, problem 4 is dastardly. Problem 5, on the other hand, is something you should be able to do. It's a little bit more on the moderate to hard side of things, but it is definitely something you should have a shot at. So we use the usual thing. This is an indeterminate power, so we feed it to the exponential of the log, pull the limit out of the log since log is continuous. Properties of log pulls the x squared down. Then I rewrite this as 1 over x squared, and then I can L'Hopital that to get this. And then cleaning that up, that gives me x cosine x over minus 2 sine x. It's still indeterminate. L'Hopital again, and then it cannot, then at that point, we're good to go, because that's 1 minus 0 over minus 2, which is just minus a half. So the limit is e to the minus a half. Yes, sir?
In the first application of L'Hopital's rule, doesn't the denominator, the derivative of the denominator become negative 2 over x cubed? Because we have x to the negative 2.
Oh, no.
2x to the negative 3.
Oh, man. Dang it. Greater. I had somebody grade this for me, and they didn't say anything about this. That's no bueno.
So you kind of have to do those rules just 2 more times then, right?
Yes, so it actually, man. Well, I do have to pass 75% of you, which means everyone who's here has to pass, but there's that. But what's that? So the way, fine. Oh, wait a minute. Part of the trouble being your own cameraman is you have to remember where you're filming. So limit. So we're limiting it. Look at words. X goes to 0, and what was it? It was log x. Log of the sine of x over 1 over x squared. Now, you're right. I should be careful. That gives me sine x over cosine x divided by minus 2 over x cubed. Thank you. I was integrating. Sadness. And so I think you're exactly right. It's going to cost me more than I thought applications of L'Hopital's rule to get to the end of this thing. Okay. I don't know what's happening in here. 3x squared sine x plus x cubed cosine x over minus 2 sine x. Yeah, and then that was L'Hopital 0 over 0. L'Hopital 0 over 0 again. Curses. Oh, that should be it, though. Why, actually, why did I have to... Wait a minute, guys. What on earth? Wait. What? Hold on a second here. Oh, come on, guys. You guys got to stop me. You know, not cool. Look, you guys got to follow along. Otherwise, I just feel like an idiot. Look, that's supposed to be what? Yeah. You saw it, but you didn't speak up. That makes it worse. You're the person I was talking about. How dare you? Sorry. Anyway, you guys are killing me. Let's see here. So we got what? X cubed cosine of x over what? Minus 2 sine x. Then L'Hopital. It seems to me at that point we're done. Because now I've got a denominator which is 2. Oh, sorry, minus 2, right? And so this is just equal to, looks like 0. See, because this denominator goes to minus 2, and the numerator goes to 0. So 0 over minus 2 is just 0. So the answer was 1. Obviously, if you got 1, and you're, oh, did I bring your quiz back? Stank. I will go get it before we're done. Should I go get it now? Yeah. Talk about your day. Obviously, someone here needs to do the camera work because I'm not up to it today. I can't lecture, much less do lecture and camera. So there's some sort of like rock, paper, scissors, like a tournament. Like best of 3. You divide up into groups, and those groups take, you do it. Rock, paper, scissors. I want to see rock, paper, scissors. Wait. All right, that's what I wanted to see.
Oh my goodness. Oh,
No, I thought he said that all of that is just like right now.
the oldest person. We have that quiz. The oldest person. And we have that youngest person.
I just got out tonight. It's had a great part.
He's 16 years old.
So that's what I get out of it.
Yeah, I should have been trying to get out of the way over the weekend, but.
What year? It was not that yesterday.
Oh, really?
Yeah, my
There's a rough part to figure
It's
out.
not basketball.
it's just like 3C. I
September.
mean, you'll probably be able to figure it out, but like I didn't understand it. He explained to me, and I didn't understand it even further.
Yeah.
But like I saw the formula,
You are
I just took a
young.
picture of the formula.
That's good.
That's good. But yeah,
That's a good thing. No, that's a compliment.
just shoot me a text.
I got camera.
Well, still. Plus the derivative of 2x.
Thanks.
Okay, I'm starting my online class too.
Really with that?
Theo 202. Is it rough?
I've taken it.
Oh, okay.
Dude, don't even play that game.
Are you an 18 now?
I think so.
Fun discussion.
Yeah.
I'm dead percent.
Well, I just kind of broke up my
We should all just leave the class.
It was still hard. That makes me feel good.
I know. No.
Yeah. It takes away from other classes.
Freshman is
I have the other college.
Dude, I just feel like, well, literally, if we say, how many kids could take with other classes? If we say anything about that?
A little bit. So, because I woke up at 10 p.m., I stayed up till like 5:30 maybe, and I woke back up at 8. So,
Really?
Yeah,
She's about to drive my car away.
I went. So I woke up really early yesterday, and I went back to my room and was going to take a nap at 2 o'clock. I was like,
How do you guys know my
yeah, I don't know.
Had you slept the night before?
Like probably 3 4 hours.
There's no good thing.
Yeah, it's like I think it was like a lot of charges.
No, Cook's just kidding.
He just looked dead.
Yeah.
I just look over you like,
Yeah, I'm just.
No, I know.
I gotta see where I gotta hit.
I know she is.
I don't know.
I know.
Take a second exam this week.
I do know.
Wait, you have another exam?
I think I got one. Oh, okay.
No, I have one quiz. We have a quiz in Converge, I know.
Yeah, we got that Friday. So we got.
It's okay with the round.
2 p.m. to 3 classes.
But it's grounded.
Yes, I am.
But I guess only have 2.
Alright, well, that's not too bad. It's a busy week though.
Yikes.
20.
What's the sound? 20. We're doing the thing, man. We're doing the thing. Wow. We are about to have a major struggle.
Granted, I missed 19
You're on
minutes.
the
But still,
Maybe that's me myself. I'm from Romania. Are you guys in Romania?
Anybody have?
No.
You are, Jesse?
Ah, I was calling you over here.
Oh, nice.
Ill-advised. Let's see here. James Earl?
You guys love it.
All right. So. All right. So sorry about this number 5. That was supposed to work out to 0, which means that the answer was e to the 0, which is 1, right? So if you got 1 on that one and you got points taken off, let me know. I'll try to rectify that situation for you. Not right now, after class, okay? Here, to calculate this improper integral, we first need to figure out what the antiderivative is of x squared e minus x. So integrate by parts 2 times. When I do that, I get this. Assuming I'm correct, which is probably assuming a bit much today, when I calculate this improper integral, I take the limit as t goes to infinity of the antiderivative evaluated at t minus the antiderivative evaluated at 1, which by my calculation, so this piece here, by 2 applications of L'Hopital's rule, becomes 0. But this guy over here gives me a 5 over e. So, any questions? I mean, the bigger idea here is if we have an integral involving infinity, what do? We take the limit as that limit goes to infinity and otherwise calculate the integral like normal, right? Questions?
So for this one, I use integration by parts like you did, but what'd you do when it came to you have to actually find the limit? Because I did, well, you had to do infinity subtract 1, right? You have to do FB subtract FA.
Well, we have to take the limit as limit as, for you, if you're using b, the limit as b goes to infinity. Where's your limit, you know?
I guess I didn't put it.
Yeah, I need to put limits.
Okay.
Right, we need this you should have a limit for. Otherwise it'll lead you astray.
Gotcha.
Yeah.
All right.
Although you might technically have the right, well, what was your, you didn't box your answer, so I can't be sure.
Oh, right
But
there.
yeah.
I mean, I got 0.
Oh, 0, no, it does, oh, okay. Now, 7 was an integral test. And you might notice that, I mean, you might notice that number 7 and number 6 are very much related, right? Like this begs the integral test by that integral. So you can use this integral and the integral test on that to show it converges. That was the idea here. But of course, I should check and see that f is continuous, positive, and this little calculation shows it's decreasing for x larger than 2. So I can apply the integral test to see it converges. Let me move on.
So is it convergent by the test?
Yes, convergent by integral test. Well, it's probably because you were missing some of this stuff, but you can show me after class.
Probably right.
Yes, any regrading, just come show me after class. I'll try to end slightly early so we have time. The class after this has a test of ultimate suffering. No, it's actually not. It's not my best test. I'm not very proud of it.
Sounds pretty exciting.
In contrast, the one I wrote for you guys tomorrow is amazing. So let's see here. This one here. This one here. So what I did was I divided the top and the bottom by n squared, right? And dividing the top and bottom by n squared gives you this formula, but that goes to 0, that goes to 0, so the whole thing goes to minus 7. All right. This guy, it goes to pi over 2 because that's getting huge as n goes to infinity, so inverse tangent of a very large thing is pi over 2, all right? Tends to pi over 2. And this one, you just got to do a little bit of algebra to realize that this is really 3 over 4 to the n power plus 42, and 3 over 4 to the n power, well, that goes to 0, right? It goes back to that proof question we had in the homework, r to the n limits to 0 for the absolute value of r less than 1, right? This is an application of that. Now, number 9 I'm overly cautious on. I'm using the alternating series estimation theorem, which says that the difference between the third partial sum, well, it's the difference between the nth partial sum and the full series is just given by bn plus 1, all right? So I noticed that if I solve n cubed equal to that, that's n the cube root of 20, which is about 2.7, so I thought, well, if I use n equals 3, I'll be safe. But if you think about it, I could be lazier, right? We could just as well we could go n equals 1 to 2, then that would put a 1 over 3 cubed over here, which would be 1 over 27. That would have still been okay. So like my answer is overly cautious. It's not the laziest answer. So you could say it's incorrect in that regard, all right? But I would hope that it wasn't counted wrong if you did what I did, but I also hope that it wasn't counted wrong if you just took to n equals to 2. If you took just to n equals to 2 and you had some of this logic, then you should have got full credit. Okay? Any questions? Yep. So generically speaking, you know, we got the theorem is this: the difference of n equals 1 to infinity minus 1 to the n plus 1 b sub n minus 1 to the n plus 1 b sub n minus the sum, let's say just j equals 1 to n b sub j, stink. This is less than or equal to b sub n plus 1, right? So for this problem, we've got bn is 1 over n cubed, right? So the way I should have done the problem to be even lazier is I should have just said 1 over n cubed. If I can get 1 over n cubed, I want that to be less than or equal to 0.05, right? But inequality is a drag, so instead just solve the equality, you know, easier to think about. Flip both sides. The reciprocal of 0.05 is what? Point 0.05 is 5 over 100, right? So if you reciprocate that, then it's 100 over 5, which everyone knows is 20. So this is 20. Then to solve for n, cube root of 20, and that's 2.7 whatever-ish. So what that actually shows me is I could use 2. Because this essentially is playing the role of the n plus 1 here. So that means I could take the partial sum to 2, and that would suffice. So like 1 minus 1/8 minus the real sum is less than 1 over 2 cubed. I'm sorry, 3 cubed, which is 1 over 27, which is, by the way, less than 1 over 20. So 7/8 actually would have worked here. But the reason I was solving, I solved the nth, I solved b sub n. I mean, generically speaking, what you do, you say bn equals to error. that you desire, and then solve for n. That's what we're doing. And then the alternating series estimation theorem says if I take the partial sum to that n, the next term will be smaller than that. Let's see here, problem 10. Yeah, this is just nth term test. That's all this is. So as n goes to infinity, we've got sine 1 over n over 1 over n, which is by L'Hopital's rule, limiting to cosine of 1 over n, which is going to cosine of 0, which is 1. That's not equal to 0, so by nth term test, this diverges. Make sense? Yes? Make sense now? I'm not saying it had to make sense for you on the quiz. I mean, I've graded this a few times. I know you all didn't get it right. Not everyone, right? I would not play poker with you guys. You're very, very crafty. Let's see. This one was just a plain Jane geometric series problem, really. So I pull out the 2 to the 4th, 7 cubed. That leaves a 2 to the 3 and 7 to the 2 inside to the n power by laws of exponents, which means this is really 16 over 7 cubed, 8 over 49 to the n. That ratio is less than 1, so it's a convergent geometric series, and it converges to this. Make sense?
Could I have used the root test on it?
Could you have used the root test? Probably. Probably could use the ratio test too. However, on the test, I might ask a little bit more here. I may basically say that, in fact, this is what I have on the test. I've got this, and then there's like a little extra add-on to this sentence. I put at the end of it, calculate the sum of the series if possible. For every last question of this tape, I've asked that. So for this one, it is possible to calculate the sum of the series because it's geometric, right? So if we did it your way, you'd miss that. I'm not saying you'd be wrong to use root or ratio test. I just don't, it's better to see it as geometric because then you also get what it converges to. It's sum.
Okay.
Yeah. Yes, sir.
So I used the ratio test and got 8 over 49, and then it converges. And I got marked off 3 points out of 4.
You have to point that out.
That's not cool. I will.
I got marked off too for that.
It means you got 3 out of 4?
Yeah.
Is it red how many points you got?
Yeah.
Oh, I see. See, but that was not in the instruction. I did not say to. I did not say to find the sum if possible. So I give you that point back. Anybody who got 3 out of 4 here should tell me after class. All right. I mean, in some sense, the graders. There is a defense for the grader in that the geometric series answer is a better answer because it also gives you this, right? But what you said was not wrong. So. And it does answer the question, so. This one is also an example of a problem where we can actually calculate the sum of the series. The sum of the series here is inverse tangent of 3 minus pi over 2. See, because if you calculate the nth partial sum, it telescopes down to just these two terms, and then as n goes to infinity, that goes to, again, pi over 2. Right? It's our favorite thing, which doesn't go to 0, but goes to something finite as n goes to infinity, right? I should find something other than inverse tangent to use. There must be some other function that's like this, but it's just my favorite. So, I mean, if you haven't noticed that inverse tangent of something very large goes to pi over 2 at this point, you're really not paying attention. And I don't think that's you guys, because you're still here. So, any questions about this one? Some telescoping series don't come prepackaged for you like this, right? What's the other kind? It can look like something where you need to do partial fractions, right? That was the other kind of telescoping series problem we saw, so look out for that. You know, that might happen. And if it is such a thing, then you can calculate the sum of the series, right? So that's where you'd be missing out, right? So here's the difference. If I ask you something like 1 over n to the, n squared plus 4n, plus 5,672. I mean, whatever. You know, this, I probably am not actually intending for you to find the sum of the series, right? It would be kind of a jerk move for me to insist you find the sum of the series. I'm not sure you could. On the flip side, if I have this, you know, can you find the sum of the series? Yes, you can. That's telescoping if you just do the partial fractions on it, right? But on the flip side, both of these can be answered converge or diverge by what test? How about limit comparison to p equals 2, right? Limit comparison to p equals 2 will show you that both of these converge, but limit comparison won't tell you what it converges to. So if you want, you know, if you want the full credit to find the sum here, you actually want to look at the second one. You want to look at it as telescoping. Now the first one, you can't find the sum. Not easily, anyway. That one you can easily find the sum by partial fractions, the telescoping argument.
But the first one is the end part of the partial fraction.
Sorry?
To find that, it's just take the limit and find that it diverges.
This one, these both converge. But this one, we could say 1 over n times n plus 3 equals to a over n plus b over n plus 3. And we'll end up with one of these being positive, one of these being negative, and there's some kind of canceling. You calculate the nth partial sum, like I did here for that one.
What test would you use
For this one, I mean, both of these, limit comparison to p equals 2 will tell you that it converges, because p equals 2 converges, and if you calculate the limit comparison, I believe the L will come out to 1 for these, and comparing to p equals 2. Yep.
Like, do you think that the test might look something more like this or more like the math problem?
I think it should look somewhat like the quiz, give or take. Yeah. What's that?
Give or take a math battle?
I mean, it's like the quiz. It's not the quiz per se, but it's like the quiz.
Like this.
This one here, we can use ratio test. We just gotta, you know, calculate our a sub k plus 1 divided by a sub k. Of course, you could use n if you don't like k. It's okay. Sorry, it's awful. So 2k plus 1 factorial is actually 2k plus 3 factorial, which is 2k plus 3 times 2k plus 2 times 2k plus 1 factorial. This guy and that guy cancel, and then you're left with k plus 1 over k squared. If you bring make these into one thing, you get k plus 1 over k, which is 1 plus 1 over k. So these two simplify to that, and this simplifies to that. This, of course, goes to 1 as k goes to infinity, and this goes to 0, so you get 1 times 0, which goes to 0, which then means that this converges, in fact, absolutely by the ratio test. Is there something mystifying here?
No, I was just thinking the value that it has to, if it equals 1, then it's inclusive, right?
Yeah, equals 1 is in. So yeah, same story for the root and for the ratio test. Equals 1 is inconclusive. Less than 1 converges. Greater than 1 diverges. In contrast, the limit comparison, right? If it's greater than 0, you can compare, right? And finite, yeah. So we don't get anything for when it's infinite? No, yeah. Oh, we're fresh out of quiz problems. Let's go back and look at the math battle. Yeah.
Could you explain more of the telescoping one? Very tall.
So yeah, so what I do is I write out the sum k equals 3 to n, right? So here's k equals 3, k equals 4, 5.
So you just keep adding.
Right, I tried to write down what it looks like for up, I mean, I have to add the first couple and then the last couple so I can see what actually cancels.
So how do you get like the n-2 and stuff like that?
This is k equals to n minus 1. That's supposed to be a 1. This is k equals n minus 1, this is k equals n. So now there's other ones where the telescope doesn't like, so you can kind of imagine different telescopes would, maybe one would be broken so it doesn't collapse all the way down to just one section. Like maybe it gets hung up so there's like 2 sections left over. You can have problems where you have like the first 2 and the last 2 left over, or even the first 3 and the last 3 left over. So you got to be careful.
So why is it n? Why isn't it k?
Why is it n?
Like, yeah, why is it n minus 1?
This?
Yeah.
Because I'm looking k equals 3 to n.
Okay.
So the right before the last one is n minus 1. Yeah.
Okay.
Yeah.
Actually, that brings up a question I wanted to ask you, because for your spring 3 test, problem 3, you actually
Spring.
have one of those problems where
Spring. So you're going to have to. You're talking in code at the moment. I need to unravel what you're saying, Joshua. You're saying my spring.
the test that you showed on Blackboard, test 3 of spring 2016.
Test 3 of spring 2016. Oh, I don't have that posted on the website, do I?
You've got it on Blackboard,
On Blackboard, okay.
and you've got an example of what you said where the telescoping doesn't take out
Spring or fall? Spring?
spring.
And which test 3?
Test 3.
My eyes. I cannot see. I see test 3. I guess I can just.
I've got it right here if you want
Well,
to see it.
you want to look at the solution or you want to look at the test?
The solution is on there. You uploaded the test with these solutions.
Yeah, so it's got to be here somewhere. I just got to find it. The problem is I've got. There we go.
Yeah, this right now.
Which one?
No, it pointed, I thought with telescoping that telescoping gets rid of everything in between except for the first one and the last one. But this one, it doesn't get rid of the first.
Yeah, this is exactly what I was talking about, the worry about, because here, you notice you've got k plus 1 and you got k plus 3. And that's the difference in the formula. The one that was on the quiz is like inverse tangent of n plus 1. So there's like a linking between subsequent terms, right? This one links terms 2 apart. So the telescoping leaves 2 things left out, is how it ends up happening. So like this one, there's nothing to ever cancel the 1, right? But there's also nothing ever to cancel that half, right? You have to go to the third term to see the third canceling the first third. And you'd have to go to the thing I haven't even written down to see the quarter getting canceled by the next quarter over here. And this also, there's also some kind of that phenomena going on at the tail of it too, because this 1 over n plus 1 is canceled by 1 over n plus 1 over here I haven't written down. But nothing cancels the 1 over n plus 2 or the 1 over n minus 3.
What cancels the 1 over n plus 1?
There's one over here that I haven't written. If you look, because, I mean, the next one back would be 1 over n minus 1 plus 1 over n plus 1. So the thing I haven't written right here would cancel that one. So it just leaves you this and that. And of course, 1 plus a half is 3 halves.
What about that 1 over n all the way to the left?
That?
Yeah.
This one?
Yeah.
That's canceled by something over here. You got to look at, you got to see the pattern is the point. But anyway, we actually are left with 4 things for this one, yeah. Indeed. The math battle, was there anything else in the math battle we haven't talked about today? Don't forget what's a probability distribution, what's it take for something to be a probability distribution? We talked about this, you should make sure you know it. Not a big deal, but what's it take for f to be a probability distribution? What? And yes, the integral from minus infinity to infinity of the function is 1. Very good. This one, you know, I hope you guys realized what the trap here was. What's the trap? Right. This is an improper integral. You have to take the limit as you approach 0 from the left and the right. And both of them separately diverge to infinity. This integral diverges. If you got that it was equal to something like 0, you're wrong. If you got credit for it, my apologies. I need to rein in my graders. But yeah, that diverges. Just so we're clear, that diverges. This one is also improper, but I think that one converges. Right? So what's the antiderivative of 1 over the square root of 2x minus 1? I believe it would just be I think it might just be the square root of 2x. I think it's this. Right? If you differentiate the square root of 2x minus 1, what do you get? The derivative of 2x squared 2x minus 1. 1 over 2 times the square root of 2x minus 1. But chain rule says then multiply by the derivative of the inside, which is 2. So the half from differentiation and the 2 from the chain rule cancel to give you back just plain square root. Yeah.
With that one, how do you know to take out the 1? How do you know to replace the 1/2?
Can anyone answer that for Josh? Why is the half different than the 1? Yes, there's division by 0 on the left endpoint, which is why we have to approach it with a limiting process. And so but this limit is harmless. This just goes to 1 minus 1. So altogether, this is 0, and that just gives you 1. So that one is actually equal to 1. The other one's not equal to 0. Again, if you got 0 for this and you were counted right, for shame on my grader. But don't tell me about it. You can keep the points. I only want to know about points that you lost that you want to have back. I don't care about the other kind. You know what I mean? So let's, yeah. The other question on the math battle, which I was fond of, but I didn't find a way to put it on the quiz, was, oh, so many fun problems. I is a nice problem, right? This one. We had a homework problem or two like that, didn't we? This one's actually very simple. How do you solve this kind of problem? Ratio test, right? Ratio test is the way to go because pretty much just divide by an. You've got an plus 1 over an is equal to that. Then you can calculate the limit of that and decide whether or not it's convergent or divergent by the ratio test. If that comes out to 1, well then I'm just being unfriendly. You know? Anyway, any questions? Yeah.
If the ratio test on that recursive definition like that came out, how would we test?
If that came out to 1, then I would always kind of I would tend to bet that it's divergent, and I would try to prove that it diverges by the nth term test at that point. I mean, that would be my hope. But it's, you know, I don't know. On the other hand, you could ask me the question, do you think you can come up with an example like that for the test tomorrow? And the answer is probably no, because I got a lot of stuff going on right now. So, sorry. And also, I already made your test. I know it's not on there, so there's that. Yeah. The test has like, I think 2 L'Hopital's problems. It's got 5 or 6 of these converge or diverge deals. It's got the estimation question. It's got the, it's got an improper integral or 2. I think it's got a probability density problem. It's got most of the things on your quiz. But it's not the quiz. So if you have struggled with the homework, it should reward you. And then Wednesday, we will actually be talking about very, very neat calculus. Hooray! What's that? No. Power series. Taylor series, Maclaurin series. The application of these ideas to interesting problems.
Talking about that today. You showed us a Taylor.
I did.
Expansion.
I was misbehaving though. You can hit it.
That was